Hello everyone. Today we are going to talk about arithmetic sequences. So last lecture we discussed all general sequences. Today we are going to talk about arithmetic sequences. I'm going to start with an example of a sequence and talk what is special about this sequence and why are we going to call it arithmetic sequence. Let's consider a sequence which consists out of 1, 3, 5, 7, 9, 11, and so on. Basically, I'm using odd numbers, right? How do we move from term number 1 to term number 2? Well, 1 looks like we added 2, right? Plus 2. And from term number 2 to term number 3, we also add 2. And from 5 to 7, we also add 2, and so on, right? Well, guys, it looks like we get the next term by using the previous term and adding a certain number 2. We are going to call this number 2 a common difference. And label it with letter Z. Okay. And this one, the first term, we are just going to label as A. Now, let's get a formula for this sequence. This is a recursive formula, not very convenient to use because to find term number 5, for example, you'll need to know term number 4, right? But actually, we can find term number 5 just knowing term number 1 and the difference. So let's see. AN equals AN minus 1 plus D, right? That's a recursive formula. Now, how this formula is going to work for like first terms. A2 equals A1, which is defined over here, plus D, right? A3 equals A2 plus D, or if we plug in instead of A2, A1 plus D, it's A1 plus D plus D, or it's A1 plus 2D, right? Now, what is going to be A4? It's going to be A3 plus D. A3 is A1 plus 2D plus extra D is going to give me A1 plus 3D. Well, you probably can guess that A5 is going to be A1 plus how many Ds? Well, it was 3D, now it's going to be 4 Ds. Every time we're going to just add one more D. Or AN is going to be A1 plus, well, if you compare 5 and 4 here, it's like N minus 1D. That's going to be a general formula for arithmetic sequence. So you don't need to know previous terms to find term number 5 or term number 10 of this sequence. For example, somebody is asking me, okay, what is term number 20? What is A20 here? We're going to look at this formula, A1, N minus 1 by D. So write down A1 plus N minus 1 by D. And then A1 is 1. N minus 1 is going to be what? 19, because 20 minus 1 is 19. And D is equal to 2. So you just multiply everything and add. So it's 1. 19 by 2 is 38. So we're going to have 39, you see? So we can calculate terms without knowing the previous terms. Okay, very good. Now, maybe we can practice a little bit in kind of finding terms. So let me give you a problem. For example, first term of a sequence equals 5. D is equal to 10. What is A100? According to the formula, A100 is A1 plus D and minus 1. And some books, by the way, they're just going to write down A instead of A1. So it's 5 plus D is 10, and then minus 1 is going to be 99, right? It's like 100 minus 1. So I have 99, 0 multiplied by 10, right? And plus 5, that's going to be 995. Very good. So we do know how to calculate terms. Next question. What if somebody gives us some terms, but don't really give us first term and the ratio? the common difference. Can we kind of figure out them? Yeah. Imagine that somebody gives us, that's an example number 2. Somebody gives us A8 equals 75 and A20 equals 39. And they're asking, what is D and A1, the first term and the difference? Well, let's write down how the formulas are going to look for this one and for this one. So A8 is A1 plus 7, right? That's n minus 1 multiplied by D. We don't know D. A20 is going to be A1 plus 19 by D, right? But we do know these two numbers. Let's plug them in. So it's 75 here, and it's 39 here. What guys we get? That we get two equations with two variables, A1 and D. We know how to solve them. They are linear equations. For example, we can just subtract the second equation from the first. So we have 75 minus 39 equals, if I subtract A1 from A1, it disappears. And 7 minus 9, 17D minus 19D. Well, let's just do calculations. So we have 36 over here on this side. And on this side, 19 minus 7 is 12, right? But was minus 12D. From where, dividing by minus 12, both sides, we are going to get that D equals minus 3. So we found our D. Can we find A1 now? Yeah. I'm just going to plug everything into the first equation. I'm going to write down 75 equals A1 unknown plus 7 multiplied by D, which is negative 3 already we know. So it's 75 equals A1 minus 21, or 75 plus 21 equals A1. And we have 96, so A1 is 96. How the formula is going to look? The formula is going to look like this. AN 96 plus n minus 1 multiplied by negative 3. You see that the terms of the sequence are decreasing, like it was 75, and then instead of getting bigger, bigger, and bigger, they're getting smaller. Why does it happen? Because our D is negative. So actually, we are not adding same number. We are subtracting same number. Or we are adding same negative number. Okay, so that's how do we kind of define other terms if we do know like sum. Now, the last thing I want to teach you is how to find the sum of first n terms of arithmetic sequence. Okay, that's going to be the formula. Sum of the first n terms of an sequence. And this is arithmetic. Okay. Well, generally speaking, we're trying to do this. I'm going to use my letter I over here. I from 1 to n, A-I. Why? Because n terms, I'll need to have n as a top index to count n terms. So it's like A1 plus A2 plus A3. The last term is AN. We want to add n terms. Do we have a formula for this? So we don't need to do all this addition on a calculator like 100 terms, but we can plug in two numbers in a formula and get the final answer. Yes. Okay, so what I'm going to do, I'm going to combine numbers number 1 with the last number, and I'm going to calculate what it's going to give me. So A1 plus AN, it's actually A1 plus, what is AN? It's A1 plus n minus 1D, right? So it's 2A1 plus n minus 1D. Very good. Now let's calculate what is going to be A2 plus AN minus 1. Combine these two terms, n minus 1. A2 is A1 plus D, right? And A1 plus n minus 2D. Well, if we combine them, we're going to get that's 2a1, this and this, right? And this d is going to kind of, we have nd minus 2d plus 1d from this one. So it's going to be nd minus 1d, which is going to give you n minus 1d. If you compare these two numbers, they're exactly equal. And actually all pairs of numbers which stay away from n's by the same amount of terms are going to give you the same number. What does it mean for us? Well, we just need to count how many pairs we have and multiply by like one pair and divide that number by 2. So how many pairs we have? Well, amount of pairs, like if we do have 10 numbers, and amount of pairs is going to be what, 5, right? So we are going to take n and divide by 2. What is going to be actually the number, the sum of these two terms, the sum of the pair? Well, you just can write on a1 plus an. You don't need to worry about this. And that's going to be the sum of n terms from 1 to n. Now, that's a formula, actually. Let's use this formula on something simple. Imagine that we want to add 1 plus 3 plus 5 plus, I don't know, 7 up to 99. We want to know what is the sum here. So how are we going to do this? Well, according to the formula, the sum is going to be n plus 1. How many terms we have here? Well, if it was from 1 to 99, we would have like 99 terms, right? But we are missing every second term. So we actually have like 1, this is term number 2. And well, let me just write down the terms, okay? So this is a1, and this is a1 plus 1d, and d is equal to 2. So this one is a1 plus, supposed to be n minus 1d, right? We know that d is 2. And what is this? What is n minus 1? To figure out what is n here. Well, we're supposed to get 99 here, right? So n minus 1 equals 98, subtracting 1, and divided over 2 is 49. So n equals 50, exactly half, like moving this one. So 50 terms. So we use the formula, we get 50 terms divided over 2. And we have first term and the last term here. The first term is 1 and the last term is 99. So we have 25 multiplied, and here is 100, and we have 2,500. Okay, that's how we use the formula. Now, maybe I'll ask you to find the sum of something. Like, give me a minute. So, self problem. Sequence is given by the first term is 55, and d is equal to 12, and number of terms is equal to 10. The question is, what is sum of 10 terms? According to the formula, we will need to know the first term, which we already know. We'll need to know term 10. According to the formula, it's a1 plus 10 minus 1 multiplied by d. d is 12. So, well, let's just calculate. a1 is 55 plus 9 multiplied by 12, 10 minus 1, right? What is 9 multiplied by 12? 9 by 10 is 90, right? And 9 by 2 is 18. So it's 108. So it's 55 plus 108, which is going to give us 164, right? No, 63, sorry. 163, 5 plus 13, 63. Yeah, so we got 163. That's the last term. Now we are going to use the formula. S of the 10 terms, sum of 10 terms is going to be a1 plus a10 first 10 over 2, and here a1 plus a10. And this is number of terms. It's 5, a1 equals 55, and a10 equals 163. We just need to add it and multiply by 5. I don't think that I can multiply numbers large like this, but of course I can, but I don't want to waste my time. So I'm just going to use my calculator. Give me a second. And where is my calculator? Oh, it's over here. So 55 plus 163 multiplied by 5. And I'm getting, okay, I'm just going to write down the final answer, 1090. So that's a sum of 10 terms. Well, we kind of solved the problem. So what other problems we can have? Well, again, you can be asked to calculate ratio and the first term in problems like this. So somebody will give you one term on a sequence and another, and I'll ask to find the initial term and the ratio. Okay, different variations of these problems. I think that's all we need to know about arithmetic sequences, and I'll see you next lecture.